Staff data. In this tab, we're going to be looking at a set of staff data, starting with their name, date of hire, date of birth, gender, age, and salary. Now, something you may not have thought before is age. Do you really want to have to go in and change the age for someone every time they have a birthday? Well, probably not. So it would make more sense that if you put in their date of birth, you then calculate their age from that date of birth. So here's how we're going to do that. To find someone's age is to take today's date and subtract the person's date of birth. That gives us the number of days, how old they are, and then divide that by 365.25 so we can find the number of years. So here's how we do that. There is actually a function called today, and it returns today's date. So if we start by typing equals and today, it's going to give us a date. A date of what? Well, we just want today's date, so we're going to go ahead and put an open and a closed parenthesis so it gives us today's date no matter when this is, and it will constantly update. So let's take today's date and subtract from that the date of birth, and then divide the whole thing by 365.25. Now that's a constant, that's never going to change, so in this case we're going to type it because it's not in another cell anywhere. Now before we press enter, I want you to note that, or remember back to that, please excuse my dear Aunt Sally, because division is done before subtraction, so we need to go back in here and put parentheses around today because we want the date of birth to be subtracted from today's date first, and then that whole thing divided by 365. Now when we press return, it will give us an age of 53.733. Okay, after about 10 years old, no one ever refers to half birthdays or 0.73. So we don't really want to show the decimal places. In fact, we just want to know the year, how old someone is, their age, what year are they. So we're going to come back in here and make these all integers. An integer, as you know, is just a whole number. So I'm going to type int, which will give me an integer, and put an open parentheses and find the integer of that whole answer. So that 53.733 or whatever that was, it will now give us just 53. And then you can copy that down your column, and you should get all whole integer ages for each staff member. Now moving over to the second table, we're going to be doing some binary encoding, where we're taking qualitative data and turning it into quantitative data. In this first column, it's asking us to find those records where it's true that someone is male and older than 50 years old. And we're going to use an if statement to create this. So let's go ahead and if this is true, if what is true? Well, what's the logical test? Well, we actually have two of them because we want to find out if the gender is equal to male and the age is greater than 50. So we are going to do two of these and find out if they're both true by putting an and. So if and the two statements that need to be true are that the gender is equal to male, and that's all the way over in this third table over here. So I'm going to go ahead and grab that value. Remember, whenever you can, grab the values or reference them. So if the gender is equal to male and the age is greater than, unfortunately there is no cell with this age in here, so we're going to have to type that one in manually. But if both of those are true, then we want to put a 1. Otherwise, we want to put a 0. Press return, and it gives us a 1, which is correct. Before I copy that down, though, I want to make sure that I've locked everything that needs to be locked. So I want both of these to change as I move from row to row. So as you can see here, the blue and the purple one are going to stay the same, but I always want to reference this same M for male for the category, so I'm going to lock that one. And technically, because you're copying it down, you only need to lock the column, only lock the row, but I'm going to lock both of them because I'm never going to change that one in particular. It's always going to be right in that cell. So I'm going to lock both, copy that down, and it's a long one. Back up, check my hints just to be sure, but you can also use your own logic and look and see if someone is younger than this 50 threshold and a female, it should automatically be a 0. So even without the hints, you can scan visually and see if you're correct. And then you're going to go over and do the same thing in the second column, except of course this time you're going to put a 1 if the staff person is female and less than or equal to 45 years old, and a 0 if that's not true. And then you can go ahead and move on. I will show you how to do this third one in just a moment. Okay, so I've done the second column, and now we're moving on to this one, and it looks really complicated, but if you step back and look for a second, you've already actually done both of the pieces. So really all it's asking is if this or if this are true, then you want to put a 1. And if neither of them are true, then you want to put a 0. So it's actually relatively easy. We'll go ahead and put an if statement, and we want to test if either of them are true, so we're going to put or. So we're looking to see if this one is equal to 1, or if this one is equal to 1, then we want to put a 1. Otherwise, we want to put a 0. And it gives us a 1, which is correct, because if either one of them is true, it should give us a 1. And you can check that all the way down. Now as we move over to the table all the way on the right, it's asking us to do, well, several things. The first one's asking is to find the average age for everyone. So it's just a simple average function. The next one, though, it's asking us to find the average age if the staff is male, the staff members are male. And then to find the average age if the staff members are female. So those are going to be count-ifs functions. Similarly, this average age, if the staff member is male and above the age of 50, well, it's kind of the same process as the second and third one, except you're going to be using the column you already created over here. So let's go ahead and run through that one. Asking us to find the average age if. So we know we're using an average ifs function. And what are we trying to average? Well, we're averaging the ages. We're averaging the ages if this column, so if any of these are equal to 1. So I'm going to go ahead and lock this as appropriate. Oops, I think I overwrote something. There we go. And thinking about this, I locked, I'm going to go back into this function, I locked this average range, and that's okay, except I still have these average salaries to do. So this is the age and the salary column is right next to the other one. So if I go ahead and remove, since I'm not copying this down, if I just go ahead and remove these $signs and don't lock them, for the first part, when I copy this to the right, then the average salary should be picked up, and that will help me finish this faster and complete the table correctly. You can complete the other two basically the same way. So go ahead and find the average age and salary for both the bottom two rows of the table. Alright, now moving on, we are trying to recreate this pivot table. Alright, so we're showing the salary by gender and age. So we have the age over here on the left and gender, female and male on the right, and then their average salary, the average salaries for both of those. So let's go ahead and click back in our main table, because we always create the pivot table from the main data with all of the data in it. So we're going to insert a pivot table and check and make sure that yours goes all the way to the bottom. I know mine goes to 391, so that's okay. And you do want to leave or make sure that the headers are included as well. So I'm going to put this in an existing location, and my existing location is that big yellow cell again. Alright, so place my pivot. Yep, there's data. That's okay. And now what are we trying to create? Alright, so let's look at our example again. And we have the ages on the left. Those are the rows going across. So I know that I want to grab the ages and put those as my rows. And then I want the gender to go across the right, so I'll put those as my columns. So those are over here. And then I want the average salary. So let's find salary. There's salary. And put it at the bottom. But right now it's the sum of the salaries, and I don't want that, I want the average. So I'm going to click the drop down arrow or the eye and choose the field settings. And here I'm going to do a couple of things. So it's going to be average salary, so I'll go ahead and type that. And while I'm here, average. And I also am going to format it while I'm here, just to save myself some time. So it's accounting and 0 decimal places. Press OK. This is a good start. We're going to do a couple of things though. One, it asks us to remove all of the totals, so we'll turn those off for rows and columns. And this should all be center aligned, so we'll get to that. You can adjust the column headings, but one thing I'd like to show you how to do is to group. So we have right now all of the individual ages. So if you're 39, here's the average female and male salary all the way down to 68. We're going to group these together in spans of 5 years. And to group, make sure you're clicked in your ages. There we go. Now when we go to Analyze and Group, it will give us the option to group the selection. So it automatically gave me my lowest and highest number, which is fine with me. And I want to put these in groups of 5 years. So I'm going to put group by 5. And this literally and very quickly will just give me groups of 5 years. So 39 to 43, 44 to 48, all the way up. So that's how you group things together inside a pivot table. So do make sure yours is all formatted nicely, center aligned. We can change from F and M to female and male. Make sure your column labels and title are appropriate, and you can move on to tab 4.